Hi class, in this video we're reviewing for our standard 13 quiz on volume. Here's the answers to the first couple multiple choice questions. Okay, so on number 2, if you happened to get 600, the reason is because it's a triangular prism, so the area of the base would be 1/2 base times height. So make sure to multiply by that 1/2 factor. On number 3, if you happen to get 144, the reason is probably because it's a square pyramid, so the volume is 1/3 the area of the base times the height. Now the area of the base has base edges of 4, but it's a square, so the area of the base is 4 times 4, which is going to be 16. So that formula will be 1/3 times 16 times 9. 1/3 times 16 times 9, which gives us 48. The formula for number 4 was the volume of a sphere is 4/3 pi r cubed. So make sure that you multiply that radius to the 3rd power. For number 5, we have to work backwards. We're given the volume, but we have to find the radius, assuming that the height equals the radius. So if volume equals area of the base times the height, then the area of the base for the cylinder is pi r squared. But we're given that the height is also the radius. So if that's 27 pi, and the pi's could cancel. So the question is, what number raised to the 3rd power equals 27? So that answer is 3. Number 6, the base is always on the bottom. That is false, because the prism can be oriented in whatever way. You know, the base is always the section which has a constant cross-section or congruent slices throughout. Checking your answers for 7 through 10. 7 is false. They say that the volume is 120, but that mistake would be knowing that it's a right triangle, which means that the base is 1/2, so they missed the 1/2 factor, because it's 1/2 times 4 times 5, so that area of the base is going to be 10 and not 20. Number 8, the cross-sections parallel to the base of the pyramid are congruent. That's false, because they are similar. And that's because it's a pyramid and not a prism. If it were a prism, then the cross-sections would be congruent. For number 9, the cross-sections parallel to the base of a cone are circles. So that's true. All of those circles would be similar. Number 10, a sphere with diameter 4 has a volume of 10 2/3 pi cubic centimeters. The reason why that's true is because we have to first calculate that the radius is 2, and then use the formula, which is 4/3 pi r cubed. So that's how you would get that answer of 10 2/3 pi cubic centimeters. In the next problem, we're finding the volume of this prism. So the base is that right here, this 12 by 12 by 12 equilateral triangle. So if we first cut that in half, then we can get that triangle. That's 12 by 6, and we could calculate that height there using the Pythagorean theorem. So working that out, the height equals 10.4. So knowing that the height of that equilateral triangle is 10.4, then we could calculate its area as 1/2 base times height, which is 1/2 times the whole base, which is 12, times the height, which is 10.4. So that calculation equals approximately 62.4. So finally, the volume is going to be the area of the base times the height. 62.4 is the area of the base. So that's 62.4 multiplied by the height of 20. So multiplying that together, we'll get our answer. So approximately 1,248 cubic centimeters. The next problem, we're finding the volume of this prism. So first step is to take that hexagon and break it into equilateral triangles. It works out to be nice equilateral triangles only because it's a hexagon. Any other shape, and you would have to use right triangle trig with tangent to figure out what the height is. But since that works out to be nice equilateral triangles that are 8 by 8 by 8, then this works out similar to the last problem. Okay, so I could get that 4 and 8. I did the last one with Pythagorean theorem. This one I'll do with 30, 60, 90 triangles, that shortcut, to show that the height is really just 4 radical 3. Okay, so then we could get that the area equals it's of this triangle right here, so that area equals 1/2 times 8 times 4 radical 3. Okay, so multiplying those coefficients, half of 8 is 4. 4 times 4 is 16, so 16 radical 3. I just simply multiplied these numbers right here to get 16. Well, that equals the area of one triangle, but we have 6 of the triangles. So to get the whole base, we're going to multiply 16 radical 3 times the 6 triangles. So that's going to equal 16 times 6, which is 96 radical 3. Okay. Finally, the volume is the area of the base times the height, so that's 96 radical 3 multiplied by a height of 15. So multiplying that together, 96 times 15 is 1,440 radical 3, which is approximately 2,494.2, and that's cubic centimeters. Third problem is a cube, so it's 3 by 3 by 3, marking up the diagram. So the cube's going to be just multiplying those dimensions together. The volume is 3 times 3 times 3, which is 27 cubic centimeters. In this next problem, we want to first find the area of the base. So the volume, just like before, this is going to be a prism because it's a constant cross-section. So it's the area of the base times the height. So the base I highlighted. So if we break that into the right triangle and into the rectangle, then the rectangle is, so marking up the diagram, it's 8, 8, and 9. So that entire length dimension is 25. So the area of that rectangle is 25 by 8. So 25 times 8 is 200. Then figuring out the area of the right triangle, we assume that's a right triangle because all the lines in this are assumed to be perpendicular. So it's 9 by 17. So finding the area of that, that would be 1/2 times 9 times 17. So multiplying that, we'll get 76.5, meaning that the entire area of the base is 276.5. So the volume would be that multiplied by that depth dimension, which is 7. So multiplied by 7. So multiplying that together, we'll get a total volume of 1,935.5 cubic centimeters. The next one, we'll find the area of the trapezoid take away the circle. So the circle has a radius of 2 because the diameter is 4, so that's a key detail. Okay, so finding the area of the trapezoid, finding the area of the circle, and subtracting them, we'll get the area of the base of this prism, because volume is base times height. So the area of the base is the trapezoid take away the prism, or the trapezoid take away the circle, which equals. So the base is 81.9, so then the volume would be 81.9 multiplied by the depth of the prism, which is 6, so multiply that by 6, and you'll get 491.6 cubic centimeters. In the next one, we'll treat the cylinder like a prism because it has constant cross-section, so the volume is going to be the area of the base times the height, where the area of the base, now we have to be careful, we're given the diameter, so it's pi times 1 squared, which is equal to 1 pi, and then the depth of it is 5, so the volume is pi multiplied by 5, which is 5 pi cubic centimeters. Again, in this next one, we have to be careful because we're given diameters. So we'll do the large cylinder, take away the whole. So the large cylinder then would be pi times 3 squared would be the area of the base times the depth of 13. And we're going to take away then pi times 2 squared for the whole times the depth of 13. So doing that calculation, we'll get 65 pi cubic centimeters for the volume. So there I just did 3 squared times 13, take away 2 squared times 13, and it had like terms of pi. The next problem, I'm going to highlight that right triangle right there to show that, so we could use Pythagorean theorem to get the diameter. Here the diameter is 6 because it's a 6, 8, 10 right triangle, a dilation of a 3, 4, 5. Okay, so if that diameter is 6, then the radius is 3, and we can get the volume of the cylinder. So it's pi times 3 squared multiplied by that depth of 8. So in doing that, we'll get 9 times 8, which is 72 pi cubic centimeters for our answer. In this problem, we have a pyramid that comes to a point, so therefore the volume is 1/3 area of the base times the height. So we get the 1/3 because we have that apex. Okay, so now we need the area of that equilateral triangle. That's 4 by 4 by 4. So if I split it in half, it'll be 2 by 4. Okay, so I could use Pythagorean theorem to get that third side, or the 30, 60, 90, that'll be 2 radical 3 for the height. So then the area of the triangle will be 1/2 multiplied by the base of 4 by the height of 2 radical 3. So that area of the right triangle, or I'm sorry, of the equilateral triangle is 4 radical 3. Okay, then we're going to multiply that by 6. But taking a step back, okay, so 4 radical 3 represents the base in that formula. So the volume is 1/3 multiplied by that base, 4 radical 3, multiplied by the height, which we're given is 6. So multiplying that together, we'll have, I'm going to carry along that radical 3, multiply the numbers, so 1/3 of 6 is 2. 2 times 4 is 8 radical 3, and that's in cubic centimeters. The square pyramid, so marking up the diagram, that's 10 by 10. So our volume is 1/3 area of the base times height. It's 1/3 because it comes to a point. So 1/3, the area of the base is 10 by 10. So 10 times 10 is 100 times a height of, well, actually, when I look at it, I see that I don't have the height. So marking up the diagram, then this section right there is 5 because that's half of 10. So the height then, when I take a look at that right triangle, then it would be a 5 by 12 by 13, or I could get that with the Pythagorean theorem. So the height is 12. So multiplying that together, then you'd get 1/3 of 12, which is 4, and 4 times 100 is 400 cubic centimeters. On this one, again, the trickier part is finding the area of that base of that hexagon. So like before, we're going to break that into triangles. Okay, so there's 6 of those triangles, where each of those triangles has to be equilateral because of the tessellating hexagon, meaning that the hexagons can fit together like puzzle pieces. Okay, so then it is, if I break that into a right triangle, then the right triangle will be 3 by 6. That forces it to be 30, 60, 90. So the medium side would be 3 radical 3. So the area of one triangle would be 1/2 times the base of 6 times the height of 3 radical 3. Carrying along the radical 3 and multiplying the numbers, then I would get half of 6 is 3. 3 times 3 is 9. But then to get the full base, we have to multiply by the 6 triangles. So multiplying 9 times 6, I'll get 54 radical 3, and that's my base. Okay, so finding the volume, it comes to a point, so we have 1/3 area of the base times the height. So 1/3 area of the base is 54, carry along that radical 3, times that height we're given, which is 15. So multiplying that together, we'll have 1/3 of 15, which is 5, and 5 times 54, which is 270 radical 3 cubic centimeters. For that answer, 270 radical 3 cubic centimeters, which is approximately 467.7. Finally, finding the volume of cones. So we'll treat these similar to a pyramid because they come to a point. So 1/3 area of the base times the height. Okay, but here being careful because we're given the whole diameter, so marking up the diagram, the radius is 3. So the area of the base will be pi r squared, which is 3 times 3, so 9 pi. So that's the area of the base. That means the volume is 1/3 multiplied by the 9 pi, multiplied by the height, which we're given is that 3. So multiplying those dimensions together, 1/3 of 3 is 1, so the answer is 9 pi cubic centimeters, which is approximately 28.3 cubic centimeters. In the next one, first of all, interpreting it, we have to be careful that that 8 only represents the radius. So maybe a first step that we would want to do is to calculate the height of this cone, so we could do that with the Pythagorean theorem. So that height is 15. Treating this problem like the volume of a pyramid, because it comes to that apex, that point right there. We have 1/3 area of the base times the height. So the area of the base is the circle, so pi r squared, which would be 8 times 8, so 64 pi. So our volume will be 1/3 multiplied by 64 pi, multiplied by the height that we calculated, which was 15. So calculating that 1/3 of 15 is 5. So 5 times 64 is 320 carry down the pi. That's cubic centimeters. As a decimal, it's 1005.3. This last problem, we need to find the radius. We could notice that that is a 30, 60, 90 triangle, in which case the long side, the hypotenuse, is 12, so the short side is 6. Otherwise, you could get that distance of 6 for the radius using sine. I'll write out what that would look like. And using sine, then you would get that x also equals 6. So volume here is, like before, 1/3 the area of the base times the height. The area of the base is the circle with radius 6. So that's 6 times 6 is 36 pi. So volume is 1/3 multiplied by the 36 pi multiplied by the height. I just noticed we didn't have that height, so we'll need to use the Pythagorean theorem right there to get it. Using the 30, 60, 90, you could recognize that it's 6 radical 3. Or using Pythagorean theorem, let me write that out. We would have 6 squared plus x squared equals 12 squared. So when you solve that, you would get x squared is 144, take away 36. And solving for x equals approximately 10.4. So that's the same as the 6 radical 3. Okay, so multiplying back here to find the volume, that goes in for our height. Our height is 6 radical 3. So this is a problem where we need to carry down the pi and the radical 3. And then multiplying the numbers, 1/3 times 36 times 6 is going to be 72. So that's 72 pi radical 3 cubic centimeters. As a decimal, that would look like 391.8 cubic centimeters. Thank you for watching, and good luck on your quiz.